Okay, so here we go with lesson 3A. This is day 2, looking at the second part of lesson 3A, chapter 3. So looking at percents or percentages here, percentages of percentages. Basically, we're looking for all the data is given in some kind of percent form, and usually talks about increasing, decreasing percents over time. We're looking at different groups. Percentages of another group, which is already a percent of something. So really a lot of confusing type of stuff here, but if you take a little bit of time and just break down what it's looking for in terms of what we've talked about as far as absolute change, relative change, and then what you're actually figuring out, it's really not that bad. Okay, so for our first example here, looking at, and before we start here, a lot of these tie directly to examples in the book. So if it's not making much sense, or if you're kind of a visual person that needs to read through it, these examples are in your book there, the second part of 3A, and I think most of them are almost exactly like the ones that are listed here on the paper. So you can take a look at those, and it kind of walks you through the steps there as well. So first one, annual interest rate of Jackie's savings account increased from 2.3% to 2.8%. And we need to describe this data using both absolute change and relative change, just so you can see the difference of where people get confused on what we're actually looking for. So if we're talking absolute change, we want to see what our new value is, subtract our old value. All right, so 2.8 minus 2.3. Going to give us a difference of 0.5%. So this is our absolute increase, basically saying absolutely concrete change of numbers. This number to this number changed by 0.5% for her interest account, or her savings account. And what we're saying there, this is called percentage points. So if they say that, percent increase was from this percent to this percent, that's actual numbers, points and percentage, and we're talking about the absolute change there. So when they say this percent to this percent, that's what we're showing there is the absolute change. Now in terms of relative change, we want to look at that change compared to where we were before. So again, we take this is the formula that we talked about last class. We're taking our new minus our reference divided by the reference. That is a funky 3, my bad. So again, we end up with a 0.5 over 2.3. I'm just running through all the steps here. Feel free to skip this one if you can. So that gives us approximately a 0.217, and then that's going to give us a 21.7% increase. So that is our relative increase. Alright, so that's percent of the original is what we're saying. So related to where we were, we had a 21.7% increase. Absolute increase, from start to finish, we just had a 0.5 percentage points increase. So there you can see big difference in numbers. You really have to pay attention to what we're actually looking for, so that we can get our data and information correct. So let's just jump into some examples here. This is where it continues in the book, and I believe this one is almost exact. Maybe it's going to focus. There we go. Autofocus. Come on. Whatever. Alright, so finally got it to focus. I don't know what was going on there. Looking at our next example, this is where we want to pay attention to the wording here and look at what they're actually asking. So it says, assume that 40% of the registered voters in Columbus are Republicans. Read the following questions carefully and give the most appropriate answer. So, if we were saying the percentage of voters registered as Republicans is 25% higher in Toledo than in Columbus, what percentage of the registered voters in Toledo are Republicans? Okay, so what we're actually looking for here is we're saying 25%. I'm just writing this out here so you can see what we're talking about. You don't have to write this stuff down. So 25% of the already assumed 40%. So we're saying of the 100% in Columbus, we've got 40% of those as Republicans. Now in Toledo, we're saying that their number in Toledo is 25% higher. So we're saying 25% of the 40% that we were talking about from Columbus. So not 25% of percentage points, but relative 25% of the 40. So what we're going to do there is we're going to take 25% or 0.25 times the 40%, because we're looking for 25% of 40. So the 0.25 times 0.4 is going to give us 0.1. So that's saying 25% of the 40% that we were talking about is 10%. So we've got in Columbus, we have 40% of the voters are registered as Republican, and then in Toledo, we're saying 25% more than Columbus, which is that 10%. So Toledo would be 50%. So 50% of the voters in Toledo are Republican. Now if we look at the next part of that, in Part B, we're saying the percentage of voters registered as Republicans is 25 percentage points higher in Toledo than Columbus. What percent of the registered voters in Toledo are Republicans? So now we're saying 25 percentage points, which remember from before, our very first example, that's talking about absolute terms. So that makes it fairly easy because we're saying our 40% of Columbus voters, and it's an actual percentage point, 25% more. So we're saying there's 65% of registered voters in Toledo being Republican. Being Republican. Alright, so you can see the difference there just in change of words. 25% higher in Toledo versus 25 percentage points higher. Okay, so that little bit of difference in words there changes your terms dramatically. Alright, moving on to the second part. Okay, so looking at in terms of figuring out percentages of figures. More specifically, this one deals with like taxes. So if you have prices of things, of items, or different dollar amounts, and looking at percents of that, this is where this ties in. And this goes with the last few examples of your homework from last class. So these exact problems here will help you. These problems here will help you figure out those if you were struggling. And if you notice in your book, a lot of times it tells you which problems to go try after you get those examples done. So these examples here are going to cover numbers 77 through 82. So as you work your way through these, you may want to go try, you want to pause the video and go try those examples. That way you can come back and look at anything that you might need to. Okay, so next example. Notice how we're looking for the basic formula that we're going to use is we take our whole number, our dollar figure, and we're going to multiply by whatever percent of tax we're talking about, and then that gives you the part of money that we have to add to figure out the total cost together. So for our first one, we have retail price of $23.76, and our tax is 7.2%. So following our percent to decimal procedures, you may have to look over those just to refresh yourself. 7.2% is 0.072. So if we're calculating tax here, we multiply those together, gives us $1.71. So for this item, we would pay $1.71 in tax if our tax percentage was 7.2. Okay, simple enough. So let's see here, the next one, retail price is 25. Tax rate is 7.5%, so we're going to have to add that to it. We're looking for the final cost, so retail price plus the tax. And there's two methods here. A lot of people only remember the initial way that people are taught in school, like what we just did there, where you have to figure out how much tax and then go back and add it in. There is another way that I'm going to show you that cuts out a step. So let's look at the long way first. And both ways are perfectly fine. There's just two different ways to go about it if you want to take a shortcut or not. Okay, so method one is the one that we just did. We've got our $25. We're going to times that by our percent. That is a decimal. So times 0.075 is going to give us 1.875 if you wanted to leave that number unrounded. And then what we do, that's the tax. So we take our $25 initial cost, and we're going to add that 1.88 if we rounded it to give us $26.88 would be our total there, price plus tax. Okay, so that's the long way. That's two steps there. You have to figure out the tax, and then you go back and add the tax. All right, method two, here's another way to look at it. If we wanted to take a step out of that and take a shortcut, we've got our $25. We are still going to multiply, but this time, instead of multiplying by just the percent, the 0.075, now we're going to multiply by 1.075. The reason for this is because we have to add that original price back in there anyway. So that 1 is like the 100% cost of $25 that we're already figuring. So if we take our $25, we're timesing it by the 107.5%. That's going to already figure the tax added in with our $25. So this is basically the shortcut way here, and we're still going to end up with the same answer. Okay, $26.88. So basically what we're doing is we're timesing that by 107.5%. The 100% for the original $25 that we have to add the tax to, and then the 7.5% of tax that's added in. So the original cost times the 100 and whatever tax percent, and that gives you your total plus the tax. Okay, so let's try that with the next one here. If we've got a selling price of $350, we're going to times that by 1.07 because we're talking 7%. We're adding that to our 100%. That ends up with a grand total $374.50. Okay, so either way is perfectly fine. You can do the method where you find the tax and then you add it to your original. Totally acceptable. If that makes sense and works for you, that's great. If you are understanding that you're taking the original and adding the percent to it for tax, all you have to do is put your tax percentage decimal with a 1 in front of it for the 100% you have to add it to. All right, it'll work both ways. Okay, so jumping now to example 6, here's another one where we're just finding the tax. So again, you have to really watch. If you are going to be using this method, then you need to make sure and pay attention to what they are actually asking for the answer. And I'll be honest, for this example, when I was doing it on my scrap piece for practice, I figured out the retail price instead, so I had to go back and change it. So make sure you watch what they're asking for if you're doing the shortcut. Don't get too caught up in trying to be quick. All right, so we take our price times our tax, because we're just looking for the tax. So that as a decimal, and then that's going to give us our tax of $54.36. And that's the tax there. All right, moving into what the book refers to as, or what I refer to as, confusing percents. Looking at percents of percents and increasing percentage points to give you a new percentage, all kinds of percents, dealing with percents, and let's see how many times we can say percents. So just overall confusing. So it's important just to understand it's not as bad as you think it is. We just have to kind of take it step by step. So for example 7, we've got the rate of smoking for 8th graders is up 44% to 10.4%. So this is telling us relative terms 44%, and absolute change, our percentage points, is up to 10.4%. Okay, and that'll come in handy when we start to write these things down. So what was the original rate? We're looking for the original percentage points of 8th grade smokers. And if you looked in your book, this is going to help you with your homework problems 83 to 84. So you can refer back to this one. I think it is, yeah, you have to do both of those. So this one will help you with that. So let's take a look at it. If we're talking about being up 44%, okay, that's in terms of relative. So we're saying if we take our, if we're trying to look for new rate, all right, what is our new rate of 8th grade smokers? We want to know what the new is. That's basically saying we are up 44% or 144%, 100 being the original, and we're up 44%, 144% times the previous rate. Okay, so if we wanted to simplify that, or if we wanted to make it in terms that we're talking about, it's 1.44 times the previous. So whatever our original rate was that we're looking for, that's what we're trying to figure out, and we're taking that times 1.44 to get us our new rate of 10.4%. So let's rearrange this here in terms of solving our problems algebraically. We want to look for what our previous rate was, so that's going to be the variable that we want to have by itself. So if we're taking 1.44 times the previous, we're going to divide by 1.44 on both sides. Okay, so now we have our new divided by 1.44 is going to be equal to our previous. Okay, so new divided by 1.44 is the previous. Now, we already know what our new rate is because we said the rate is up 44% to 10.4. So the 10.4 is what our new rate is. So we're going to say we have 10.4%. Now I'm going to leave this as a percent because in relative terms we're saying we have a new rate and a previous rate that are both percentages, and we're just increasing them as a relative term, 44%. Okay, so our new and our previous are absolute terms. The up 44% is a relative term. So that's why we changed that to the 1.4. Please don't lose focus again. There we go. Maybe. Okay. So 10.4%, we're taking actual 10.4 divided by 1.44. And that's going to give us 7.2. Okay, so hopefully that makes sense. You know, we used our relative formula from the beginning from our first set of notes, saying that we're taking a percent times where we started, and that gives us our new rate. And then we kind of move those around according to our algebra laws, algebra rules, whatever you want to call them. And then we can plug in that we already know our new rate, we just have to figure out what the previous is. So this is saying that if we start at 10.4, or if we ended at 10.4%, and that was up 44%, what our previous would be 7.2. And if you want to plug that back in, you know, up here, 1.44 times 7.2 should give you 10.4. Okay, so originally 7.2 up to 10.4. Hopefully that all makes sense. All right, moving on to the last few examples here. Okay, now these ones, I'll be honest, I had to read them a few times to make sure that I was answering them properly. Now we're going to focus. Hopefully I figured out the focus there. Apologize for that. So the next one, shifting reference values. Are we really shifting reference values? Is this true, false? You know, it looks right if you look at it on paper, you know, in terms of numbers wise, but is it actually saying a true statement? So this is where we almost need to kind of work our way through the problem to make sure that it does make sense. Okay, so an example here, number 85. And you guys will have to do 86 and 88. I'm working through 85 and 87, so the other ones are similar to this. So 85 says, if the national economy shrank at an annual rate of 4% per year for 3 consecutive years, then the economy shrank by 12% over 3 years. So this is where we're saying, is this true or false? And then tell me why. So common sense would say, all right, 4% for 3 consecutive years, 4% times 3 years is 12% over the 3 years. So that's what we're trying to say. Hopefully by now you figured out that if we're taking percent increase or decrease each year, that means we're lowering our figures, and it doesn't, you get different numbers, right? So when we talked about in class the change of salaries, Clint and Helen, or whoever they were, I think those were the names, one person started out at a higher rate, so their percentage of that number was different. So if we're talking of dropping a percent each year, you know, we're dropping lower and lower each year. So let's see if this actually does work out. Okay, so for example here, we're going to say for year 1, where we start at. If we're talking about we've got 100% of the national economy, so we're going to say 1. Okay, we're dropping 4%, so we're going to take that 1 and we're going to times it by our 96% to where we are going to end up. Okay, because we're dropping 4%, so this is basically the equivalent of down 4%. And this is kind of like taking out a step. If I wanted to figure this out, I would say, all right, what's 4% of that? And then I would subtract it from there. But those are easy enough numbers. I know that if I'm down 4%, my new total is going to be 96% of my original. Okay, so I'm taking my original times 96%. So obviously 1 times 0.96 is going to give me 0.96, which means I am now at 96%. So instead of being at 100%, now I'm at 96%. Okay, so that's year 1. I'm down 4%. Year 2, I am going to continue to drop 4%, like I said, 3 consecutive years. So now instead of being at 100%, now I am at 96%. And if I'm dropping 4% from that, I have to times that by 0.96, because I'm taking 96% of my new original value. Okay, so I'm going to times that by 0.96 because I'm dropping 4%, and that's going to give me 0.922. So now, from where we started year 1, I'm at 92.2%. So I'm still down. And we have to go for 1 more year to see if we're actually having a total of 12%. So this is my new original. I'm no longer at 100%, I'm no longer at 96%. Now this is at the end of year 2, I'm at 92.2%. So I'm taking my 92.2%, and I have to drop 4% yet again. So I times it by 0.96, and that is going to give me a total of 0.885, or 88.5%. Okay, so what we are basically saying there at the beginning was over the 3 years we should shrink 12%. So let's see how accurate that is. If we started at our 100%, we're now at 88.5, which is only a difference of 11.5%. Okay, so this statement would be false because we did not drop 12%, we only dropped 11.5%. So I guess you could say that's good because we didn't drop as much. And that again goes by our figures were decreasing each year, so taking that 4% off of the lower figure is going to make it lower and lower each year. So it's going to continue to get off from that 4 times the 3. You know, if we went by 4 years, 4 times 4 would be 16%. We'd be a little bit less than that yet because we continue to decrease each year. Just talking about percentages of lower numbers. Okay, in your book, the examples that are in there show you exact dollar figures. So it's talking about if your interest rate goes from this to this, what is your percent profit, or things like that. It gives you exact numbers to plug into these tables that you would figure out. So you can refer to those for your homework. Trying to see. Yes, I think number 86 will actually work better if you try to use an exact figure. And 88, I think you can use percentages. At least that's what I did. So you can do it either way. You can go figuratively in terms of percentages, or in your book it shows actual dollar amounts. If you said hypothetical, I start with this, and then my percent changes by this, you can actually figure that out that way. Okay? Because remember, percents are always just out of 100, so it's able to be related to any figure that you start at. Okay? So if the profits in your consulting business increase by 4% 1 year, but then they decrease by 2% the following year, your profits are up by 2% over 2 years. So they're saying if we have that 4% increase, but then we decrease by 2%, we're still up 2% according to the original. Now, let's see how accurate that is. So just by looking at this, it should throw up a red flag whenever we're talking, we go up by this much, but then we decrease by this much, because these are two different reference values. If we go up by 4%, that's the original. If we decrease by 2%, that's the new original with the increase. So we need to see how accurate this is. It's probably going to be off, but let's check. So anytime you're talking about percentages over different figures, they're probably going to be different than just saying the absolute percentage point change. So again, let's think of in terms of 100% for our reference year, if we're starting at 100%. So we're going to say 1. And we are increasing by that 4% on 1 year. So whatever my figure was, 100%, with another 4%, I'm going to times it by 1.04. Okay? So I'm timesing that by 1. Should give me 1.04, which means I am 104% according to my original. All right, now, the second year, we decreased by 2%. So we have to take our new value, 1.04. All right, so we increased 4%, so our new value is 1.04. And we are decreasing by 2%. So this is where you have to be careful. We're not talking about subtracting 2% from this figure. We're subtracting 2% of the entire thing. 2% of this as being our new 100. So instead of saying 1.02, it's 0.98 because we're talking about 2% less than our 100%. This is our new 100% for the year, so 2% less than that. Okay, 2% less than our original 100. All right, if we figure that up, 1.04 times 0.98, 1.0192. So if we look at that there, this is our increase, which is only 1.92% up, which is not quite the 2% that we were originally saying. So this would also be false because we fall just short of that 2%. Okay, so there's your homework, page 143. You've got 77 through 84, and those are mostly like percentages of different groups. So you can use that whole times the percent gives you the part, and if you have to, you may have to set up like an equation there. And what I think I'm going to do is, while I am out of town, I may put together another video of the homework questions for this assignment here, and I might send you that later in the week so that you can double check it, and we can go through any questions we have in class. You know, maybe I'll do that and see how it goes, and we can discuss it. If you want to keep doing that versus going over things in class, we'll kind of go from there. All right, good luck to you, and we shall see you next week.